by the fact that how we see at night is not particularly well understood. And neurophysiologists who study animals like the horseshoe crab are hoping to learn about the neural basis of night vision. While there's quite a bit of information and data about how the eye works in describing how crabs see during the day, there's very little data available for how the system operates in low light level conditions. And what Nadav set out to do was to rectify this and build a device and a system that would be able to optically stimulate individual retinal receptors and characterize the light responses of these individual receptors under dim light conditions. And this project involved sort of a range of system design and building. He had to work on issues of putting the control and modeling interface together. He needed to build a simulation system based on a green LED and a light pipe in order to interface that into the eye of the horseshoe crab. To do that, he needed to build a very reasonably sophisticated 6 degree of freedom mechanical stage, and then he needed to also worry about the measurements that needed to be made after the excitations were completed and create a rig to do all of this. So here's what he ended up accomplishing. This is his horseshoe crab. That's the eye of the horseshoe crab, which is blown up here, and he positions his light pipe in a way that's perpendicular to the interface with the eye, and that was important. And this whole device over here is designed in order to, once you get the pipe into the right direction, to keep it, to allow him to orient that surface perpendicular to the eye, regardless of where he had to put it. He also had a recording chamber that he needed to get into, gain access of the optic nerve, and he was recording from the optic nerve while doing the simulation here, and he was actually able to get recordings that were instigated by different levels of light shining into the eye from the optic nerve. These recordings from the optic nerve, and then he flooded the system with ambient light by turning up the light and watching the response of the system until it sort of turned down the gain and then brought it back up again. Anyway, this is really quite a remarkable tour de force and well deserving of the Biomedical Engineering Senior Design of the Year project.